Hi everybody. We're going to do our next unit virtually, and so hopefully this works out okay and everything makes sense to you guys. Our last unit that we're going to be covering in this course is going to be on polymers, which maybe is another way of saying plastics. So we're going to be looking at some of the uses for plastics, some of the chemistry around it, some different kinds of plastics, and a few issues we should all be aware of. So first of all, what are polymers? And if you look at the word polymer, what it literally means is poly means many, and mers means parts. So what polymers are molecules that are typically long chains of individual subunits that are repeated over and over again. So you can kind of see what I mean in this picture. If you think of these beads that you can see on this part, you can connect them in a big long row to make a big long string, and the polymer would be the long string made of many little parts, and the individual pieces all by themselves we would call monomers, where mono means one. So polymers are very widespread, both naturally occurring and artificial ones. And you can see here as an example of a natural polymer is cellulose. And cellulose has this sort of fairly complex molecular subunit that is repeated again and again and again to make very long strings. And these strings you can kind of see in the picture here on the left. We have these little subunits repeated again and again. They make these long strings which are sort of bundled together to make microfibrils. These are bundled together again and again. And the final thing that we have is a cellulose fiber. So this cellulose fiber you can think of is kind of like if you think of a piece of cotton, like a cotton ball, the little individual strings would be like these cellulose fibers. And so of course we use cellulose fibers from cotton and other materials to make things like clothing, fabric. Other types of naturally occurring polymers are called nucleic acids. So RNA is one example. DNA would be another example. These have a small number of possible subunits called monomers, which then are strung together in these long chains, and this is what we would call one of these nucleic acids. Proteins are another example of a natural polymer where the individual subunits, the monomers, are called amino acids. So amino acids are all linked together. They're connected by things called peptide bonds. And what you end up getting are these long chains. These chains often will bundle up and make a protein. There are a huge number of possible structures for proteins because there are 20 naturally occurring amino acids that can be used in any combination, and each combination would be a unique protein. And of course you could also vary the length of the chains, so there's a huge, staggeringly large number of possible protein structures you could get based on these individual amino acids. So hemoglobin is just one example of a protein. It's the oxygen carrying protein that we find in blood. And this picture I have is actually a little bit misleading because hemoglobin is not the same molecule, not the same protein that makes meat red. It's the protein that makes blood red, but there's a closely related protein that you find in meat called myoglobin. Anyway, this is made up of myoglobin and hemoglobin are made up of very long strings of amino acids or polymers that bundle all up into this kind of structure that you see here on the right. Hemoglobin is actually a bit more complex than that in that it has 4 individual chains that all come together to make this big sort of glob that you see over here. But yeah, that's what a protein looks like. And we have these kind of fancy ribbons to kind of show what the structure looks like. So polymers certainly, are very widespread in nature, but probably when you hear about these talked about more frequently, it's in the context of artificial plastics or sort of human-made compounds. So one of the very first synthetic polymers, or partly synthetic polymers, ever made is something called nitrocellulose. And it goes also by the name of gun cotton that you can see a picture of right over here. So nitrocellulose was actually accidentally made the first time. What happened is there was a chemist who was working in his kitchen actually, and he was using concentrated nitric acid. Concentrated nitric acid, which is HNO3. And what happened is he actually spilled a bunch by accident on his counter, and so his first instinct was to grab the nearest thing to clean it up, which was a cloth. And cloths are, most fabric is made out of cellulose or cotton. He soaked it all up, threw it in the sink, continued to clean it up, and he kind of cleaned up his workspace. Then he went back to the sink, and there was this cloth that was soaked with nitric acid, and he rinsed it out, he wrung it out, he did his best to get all the nitric acid out, and then he went and he hung it by the fire to dry all the water off. So it sat there, it dried out. When it got to dryness, what happened is a spark shot out from the fireplace, touched the cloth that was drying there, and it immediately burst into flame. And it disappeared. It was gone. There was no smoke, there was no residue, no nothing. It just sort of immediately erupted. So what happened was the cellulose chains, and the cellulose, of course, is a natural polymer. It was modified by the nitric acid to make this structure that you can see right here. This would be the subunit that repeats, which is called nitrocellulose. And nitrocellulose burns extremely well. And it was almost immediately put into good use, or depending on your point of view, whether this was a good use or not. It was used to make gunpowder, and in particular, it made a kind of gunpowder that, when lit or when ignited, didn't create any smoke. So this was actually very important, and it led to all kinds of military applications in that way. Another use of nitrocellulose was it led to the birth of the film or movie industry. And the way a movie actually works is you have a reel, and on that reel is a very long strip of a flexible, transparent plastic, and there's individual pictures that are basically printed sequentially on that film. Before the invention of plastics or polymers, the only real substrate to put pictures on was glass. Glass, of course, is not flexible. You can't roll it up in a reel, and so they couldn't easily make movies with that. So nitrocellulose, with that, they were able to modify it further and produce a material called celluloid, which is about 80% nitrocellulose. And with that, they could make these very flexible plastic films, which then allowed them to print images on that and make movies. And so the invention of celluloid, or discovery of nitrocellulose, was believed to be a necessary precursor to the development of the movie industry. Now, you have to be very careful when movies are, printed or stored or being used, because nitrocellulose, as I said, is extremely flammable, and so fires in movie houses used to be very common because the lamps often were very hot to produce enough light, and it required a great deal of care. Nitrocellulose is still used today. In fact, I'd say the two most common places you're going to see nitrocellulose is, first of all, in ping pong balls. And if you ever have the opportunity to try this out, if you put a ping pong ball in a fire, you'll see firsthand how well these things will actually burn. Another common use for nitrocellulose today is in guitar picks. And this is something I have not seen lit on fire before, but presumably you'd see something quite similar. The first completely synthetic polymer, because nitrocellulose was a modification of a natural polymer. The first one that was completely synthetic was a polymer called Bakelite. And Bakelite was first made in 1907. It's actually a lab that we do in our organic chemistry courses is making this, and students get to see what that's like. It's used by reacting phenol and formaldehyde, which are both common and cheap materials. And the resulting plastic is very hard, very dense, and very brittle, and has characteristics very similar to like dry clay. And one of the very first things it was put into use for was as a replacement for clay for making things like poker chips. It would also be useful to make dishes, cups, mugs, things like that, that were sort of heavy and dense and brittle, but also probably tougher than clay would actually be. So very quickly after the invention of some of these very early polymers, there was sort of an explosion in both interest and research activity into studying polymers, developing new polymers, and creating the plastics that are so ubiquitous today. DuPont, which is a very large chemical company which is still going strong, created an experimental station with basically the whole purpose of developing new types of polymers. And so one of the first things that they needed to do was hire someone who was an expert in polymer chemistry to come work for them. And they were attracted to a Harvard scientist named Wallace Carruthers. And this is a picture of him right over here. He was initially very reluctant to go and work for them. And one of the reasons he said is that he suffered from some pretty serious mental health issues, and his actual quote was, "I suffer from neurotic spells of diminished capacity which might constitute a much more serious handicap in industry than it is here in academia." So he was, worried about that particular thing. However, DuPont was relentless. They offered him a salary of $500 a month, and that was actually double the salary he was receiving already at Harvard. They also offered him a huge amount of research funding, trained scientists to work under him, and the very key thing is that he was allowed to pursue whatever he thought was most interesting or most useful. They didn't try to guide or direct what he worked on at all. The only, proviso was that anything that he discovered was the property of DuPont. One of the first things that he took over was development of a new polymer that was invented actually not by him but by somebody else, but he perfected the process. A chemical which was called Duprene at the very beginning, but now is known as Neoprene. Neoprene plastic is used all the time. It's sort of a foamy kind of material that you can see. It's the kind of plastic that is coating these sort of fuzzy weights, or the kind of foam that you might find in these cozies that you'd put around a can of beer to keep it cold. And the original neoprene that was developed smelled terrible. So Wallace Carruthers and his team developed a new process to make this that took away that really terrible smell. So that was important for people adopting this. So he was very interested in the chemistry of a new kind of polymers called polyesters, and he was doing a lot of work in development and research. And in particular, what they were looking for was a substitute for silk. And silk is a naturally occurring polymer. It's a protein-based polymer that many different types of animals or insects will create. Spiders, which are not insects, of course, create silk to build their web. And the kind of silk that people use as a material for making clothing and things like that comes from something called a silkworm. And the silkworm, you can see a picture here on the right. At one stage of their life cycle, they wrap themselves in these cocoons, which is one single strand of silk that's wrapped around them again and again and again, many, many times. And so what he what the problem was is that silk was very expensive and very difficult to make on any sort of scale. And that's because these insects had to be cared for and fed, and then it takes a long time for them to get to this stage. It was time consuming even once you had these little cocoon balls that you see here on the right to then convert that to actual silk material. So they were looking for some kind of synthetic material which behaved like the silk that they could use as a silk substitute. So they initially were looking at polyesters and then began to work with polyamides, which is another kind of linkage. In 1938, they eventually came up with a material which was called polyamide 6,6, which was marketed under the name Nylon. And so DuPont began commercialization of this material, and it was a huge success when it first came out. In fact, what it was initially used for was as a replacement for silk to make women's stockings. And you can see that in this ad that you see right there. At the time, it was very fashionable for women to wear silk stockings, and because of the way they worked, the silk itself was created in a sheet. The sheet was then formed into the stocking shape, and there was a seam that ran up kind of the back of the leg on the silk stocking that you could see, just like you'd see a seam in any other piece of clothing. So the the silk, because it was so expensive, it limited the length of the stockings that they were able to make. So typically they were short, and if you had a short stocking and a long dress, no skin was exposed and everyone was happy. So when nylon came out, which was originally supposed to be a cheaper version of silk, it was such a huge success, and people were lined up to try to buy these things. They became actually much more desirable than the old-fashioned silk before. And so they were sold initially in these cans where it says fresh nylons, and in addition to the nylons that were in the can, there also was a little black charcoal pencil. And the idea was that when you pulled them on, you would use this pencil to draw the seam up the back of the leg, because these nylons, when first made, were seamless. And to make them look like actual real silk, you draw in the seam. Of course, people didn't want to be seen wearing the old-fashioned silk. They wanted the new material. So most people threw away the pencil and didn't use that particular thing. And yeah, so this was great. One thing that made these nylons even more desirable was the fact that war broke out a year later, and DuPont took all of its nylon production and transitioned it away from making these stockings and towards making parachutes for the Allies for the war. And so what happened is you couldn't find these nylons anymore. That made them scarce, and that really drove up their value and appeal. So yeah, so nylons were a gigantic commercial success, and of course you still see nylon today. I've actually read before that people think that the trend over the last several decades of women's dresses going from very long to getting progressively shorter was in part made possible by the discovery of nylon, because nylon was very easy to make stockings of any sort of length that you wanted, where silk, because the material was so expensive, was sort of limited in how long the material could get. So by making stockings as long as you wanted, you could also make dresses as short as you wanted, and so you can see how that connection fits that way. Okay, we're going to take a little break for now, and we'll resume in part 2.